Hi, I'm Josh Anderson, and I really made this presentation, Managing Big Data in Orthopedic Research, to hopefully help those that want to start doing some big database research, because one of the big parts of being successful in that is being able to digest and manage the data. So today I'm going to go over some general principles, some tips on data organization, and then some essential functions that you'll need kind of moving forward. So first, kind of going over some pros and cons of big data type studies. They are very well-powered studies, which is often not the case in orthopedic literature. And they can capture a large population over a broad timeline. And when you are using a database, you have the potential to answer a number of questions and get potentially multiple papers with the data. However, you have to understand the process behind using this data and managing the data, and then you essentially can repeat it for multiple studies, and it can become very fruitful for you in terms of research productivity. And it can be a gift that keeps on giving. So if you develop the process behind using a database and other people then go and use the process that you developed, you can be involved with a lot of research, and other people will continue on with your work where you are going to be a co-author on those studies and be able to help them too. So it is increasingly popular, especially in some fields in orthopedics. In particular, the total joint arthroplasty literature has numerous studies using big nationwide database type studies. So knowing how to do this is very important going forward. And the data is often just given to you because a lot of it's collected in the database format. So you're doing minimal chart review, you're not really reading a bunch of x-rays, and a lot of that more time-intensive, tedious work involved in collecting the data. So in terms of the cons, it can be a heterogeneous group of patients in your data set, and it is pretty tough to capture all the confounders, so that's always an inherent weakness to these studies. And because of that, there's a potential for substantial bias in your research, and that'll be something that you have to disclose when it comes time to publish your results and write a manuscript. And you are at the mercy of the quality of the database. So if you're using data from a database that's sloppily kept, then you're going to get that in your data, and you're going to have some shortcomings. Whereas if your database is really meticulously kept by those that are inputting the data, then the risk that you're getting very low quality data is then substantially lower. Another downside is it can be very time consuming to get others involved in your research in a significant way. If you're the only person who knows how to use a data set or a database, then you have to spend a lot of time to teach other people how to use it. It's unfortunately not as easy as just giving them an Excel file and letting them kind of go at it. Usually there's some nuances that you're going to have to show them to be able to manage it on their own. So, and if you are the one who manages all the data, you're often doing a lot of this work on your own, so that can be a bit more time intensive there. And there's a lot of trial and error, especially starting out. If someone gives you a lot of data, you have to do a lot of your own data quality assurance, so to speak. So you're kind of testing the data to check the quality of it and making sure that what you're doing with it still works, so that the analyses are accurate and you're reporting on accurate information. So now moving on to some tips on organizing your data. So I would recommend casting a broad net with your data population pool and then fine tune it. So rather than being very specific with your data request to answer one clinical study, I would be very broad, and then you will know how to use the database and trim down the data for all the subsequent studies that you are going to do. So cast a broad net, because if you have more data, you get more studies out of it. So it is important to stay ethical. So you don't acquire the data, then hypothesize. You want to make your hypotheses before acquiring the data. It's easy to do the opposite there, which, then you're kind of mining a database for studies, which is something you should try to avoid. So it's really important that you know your data in and out. You need to know what each variable represents that you're given. Oftentimes you'll have a go-to person who gave you the data, and you will be probably in frequent contact starting off with them to understand the ins and outs of how the data was captured and recorded, and what criteria they used to make that variable. So similarly, you need to know the holes in your data. So database studies have significant weaknesses. You're going to have to report on them, and so you have to therefore know them. And an opportunity here exists for a potential workaround. So for example, if the database doesn't include data on a specific variable, for example, if they don't have a category on who's a smoker or who's not, there's potential workarounds, because there are, for example, ICD-9 and ICD-10 codes for diagnosing tobacco use and smoking. And if the database records that well, then you can use that as a surrogate. So there are potential workarounds, but you do have to know the holes in your data. And one thing that you're going to have to do and have to learn how to do is apply functions and equations to your population as a whole. Because if you are dealing with a population of several 100,000, then that's way too much data to really manually go through each person to review it. So you want to be able to develop an equation or a function that then you can apply to the entire data set. So you also need to be able to identify duplicate or missing data entries, which is often found in databases. So you need to be able to find those and identify those. And another tip is, if you're dealing with big numbers, if there's any ambiguity with some of the subjects, if the equation that you're making doesn't work out, or if the data reporting on a subset of the subjects just isn't good, I would just exclude them. Don't work really hard or potentially sacrifice the quality of your data and analyses just to include a few people if your studies are otherwise well powered. When possible, I'd create binary variables. So 1 being yes, 0 being no. And generally speaking, for a lot of these analyses with big database studies, categorical variables are easy to work with, and they make more sense when reporting your results. So you want to know how to also reinterpret variables. So sometimes you may want to change a continuous variable to a binary or a categorical variable to have an analysis that makes more sense, especially with regression analyses. And one of the biggest and most important tips is to use Excel to create and manage your population. So almost all stats software, at least the ones that I've used and encountered, know how to import Excel sheets into their analysis data sheet. However, the data sheets in this software are not functionally as good as Excel, so I would very highly recommend using Excel to manage your population. So, and then in Excel, you use that to create and adjust variables. So within it, you're going to use the data that you're given in the database, and you're going to create certain variables for your analyses. So using Excel makes that much easier. So then, on the opposite end, you want to use your stat software for most of the analyses, because with Excel, doing complex analyses, regression analyses, etc., is cumbersome, and it's not very intuitive, and it's usually better in the stat software itself. So again, Excel is your friend. You need to learn how to use functions in Excel. If you're given multiple data files, so for example in the window there for my File Explorer, you can see there are numerous data files that I was given for this study. I would highly recommend that you synthesize the data in these multiple files and have it in one main data sheet that you will then import into your stat software, and then that main data sheet is where you'll also create all the variables that you're going to be using for your analysis. And then once you have your Excel file, you want to use the top row, so the top cell in the row, as the variable title, and then the rest of the column is the data. Okay. And again, Excel makes managing big data a lot easier. You can see on the far right, that's just a snapshot of one of the studies that I did. That's one of the data files on medical data, and there's over 1 million rows of data there. In dealing with all of that in any sort of stats software is very difficult. So another thing you need to do is you freeze the top row, and this will make more sense in a second. It makes the data management a lot easier. So if your first column is the patient identifier, okay, so again, you can see on that far right, there's all the code there. That is used to individually identify the specific patients in that study. So that should be your first column, and then your top row is your variables. So you can freeze those simultaneously, which makes the whole process easier. So you can see here under the View tab in Excel, you go to View, you click on Freeze Panes, and you can just freeze the top row if that's all you need to do. Otherwise, if you see in the screenshot below, you highlight a number of cells in the second column, starting from the second row going down, and then you just hit Freeze Panes. And that way you freeze the top row and the top column, so that when you navigate further in the Excel sheet, for example, if you're in column AZ looking at data in row 500, you can still see which variable it is and which patient it is, because you'll still be able to see the patient identifier and the variable title. So next thing you want to do is apply filters to each column. This helps with sorting, and it helps with looking for errors with your equations, and you can also assess the prevalence of certain variables in your data sheet with it. And this is how you do that. You click on the Data tab, which I have in a red box there, and then you click on Filters, and that applies filters across the board in the top row. And then you can see in the screenshot in the bottom right of the screen, if you click on that down arrow on the top of the column, that brings up, basically it shows you the data that's present in that column. And in this particular column, I made it a binary variable, so you see a 1 or a 0. And then you can go to number filters, for example, and you can see there's a bunch of options there, and you can really customize your filter. So it's really important to get used to using that. And then you want to sort important columns alphabetically and numerically. For example, what I always do is I sort my patient identifiers alphabetically, and then if the studies that I do involve surgery, so then I sort the date of surgery chronologically with the oldest to the newest, just as an example. So you want to get good at sorting these, and how you do that again is under the Data tab. You click on the Sort button. You make sure your entire data set is highlighted, which it automatically does for you in Excel, and then you can add different levels on how you want to sort it. So again, you can see here my claim ID is my patient identifier. I sort it A to Z, and then going forward you can make different levels of that. So You want to save all the equations that you make when you're creating variables if you're not going to change the data that you use to create the variable. Okay, and this again will make more sense here in a second. So again, you can see here, there's an equation there under the Psych CPT. I used that functional equation to develop the variable within my main data sheet, okay? And you want to keep those equations in there, especially if you're going to be doing repeat studies using very similar methods, because then you can just reapply those equations to a new data set to make your life a lot easier. However, this is what happens when you change the data or delete the data that you use to create that variable. So, for example, again, you can see my equation that I use to make this variable here in the top box. And then if I delete that data in row R3, or sorry, column R3, then all of these errors will pop up. You see the number sign and then reference. So that means that that equation no longer has the reference. So as long as you're not editing, as long as you're not deleting or editing the data that you're using to make your equation, you're fine. And editing the data is really okay as well, because then it just changes the output of the equation. But as long as you're not really getting rid of it. So if you are going to get rid of some of the base data that you're using, what you need to do is you need to copy and paste the values in that column. So again, the picture there, I've highlighted the entire column. I copied it with Control-C. There's other ways to do it, but that's the easiest way. And then you right-click over it, and you can see different paste options show up. And there with the numbers is paste values, and that just pastes the value in the cell, and it takes the equation away, so that when you click on the individual cell, it's not going to show the equation, it'll just show the value. So you also need to make sure your variables are appropriately formatted, especially when you're moving your data into your data analysis software. So for example here, you can see on the left there's a column that says first service date. That's basically the date of surgery. So you want to highlight the column, you want to right click, you click on format cells as shown here, and then you go down to date and you make sure it is on the correct date formatting that you want. I like that the top one that's selected that works for my data, but really you can click any of those. In this way, when you import your data into this stat software, it recognizes that column of data as date data. And if you can't figure out how to do something, and I did this a lot early on when I started working with this type of data, you just ask Google and YouTube. You can see a screenshot here. Asking Google how to do stuff works very well, and also there are numerous videos on YouTube on how to do very specific things in Excel. Just go to Google or Bing or whatever search engine you use and search for it, and you will find help. So now I'm going to go over some essential functions that I think you really need to know how to do to manage a lot of large data in multiple Excel files. So I'm going to go over if functions. I'm going to go over a little more in depth column filters, the VLOOKUP function, as well as pivot tables. So if functions, these are critical in terms of using the data that you're given in the database and creating the variables that you're going to subsequently use in your analysis. So you can see here in this screenshot, this is what will show up in Excel once you start the if function. So you put in an equal sign, you type if, and then it shows up in here. You can see right now bold is the logical test. So to put the function in, or to do this function correctly, now you then do the logical test. Okay, so that is usually involves clicking a cell or putting a number and then doing greater than or equal to, etc., and then you hit comma, and then that moves to value if true, and then you can put in the value that you want if that function is true. So if you're making a binary variable, that would be 1, and then you hit comma again, and it will bold value if false. Then you put in whatever value it wants to spit out if that logical test turns out to be false. And one of the beauties of the if functions is you can put a function within a function. So again, if you're looking at the screenshot below, these can get quite long and tedious, but they can be a very powerful tool where you can basically synthesize data in numerous columns or numerous cells throughout your spreadsheet to make your one variable. Another really important thing you can do with the if functions, you can do if and or if or. So basically when you do if and, for your logical test, you put in a number of arguments, or again, logical tests. That term is used interchangeably in Excel. So you put in a number of things you want to either be all false or all true. So if you make a bunch of binary variables and you want to make a variable where all those binary variables are true, so again, a 1, you can click on that cell for your first argument. You do click on the cell, equal 1, and then you hit comma, and then you can continue putting in logical tests. And basically, again, you use this if you want all of those to be true, then you can spit out a certain value. So if I want 5 of my binary variables to be true to then create this other variable, I will make an argument that each of those have to be equal to 1. And then you do comma, value if true, and then you can put whatever it is, a 1 or a 0 or whatever, and then value if false. So then if or is similar in terms of you can enter a number of logical arguments. However, the basic difference here is that instead of all of the functions needing to be true or false, any of the functions can be true. So if you are looking for a 1 or a positive value through a number of variables, and any of them can be true to be included in the population or whatever variable it is you're creating, you can do the if or function. So it's another very powerful tool. And again, this is what it looks like. So you can see if and then in the bottom, test 1, 2, 3, 4. That's just text that I entered. That's not an actual logical test, but this is what your screen will look like if you're putting in a number of logical tests or arguments in your if and function. And this is what it looks like, I guess, in one of my Excel sheets. So I use this frequently when I'm trying to make a study population. So you can see here in the equation sheet, it looks at cells in column K, F, BF, E, AK, and I. So again, those are all a number of functions where all of those have to be true. And then if all of those are true, then it will spit out a 1, which is again in the value if true spot, or a 0 if any of those are not true. Okay, so that's what it looks like. So moving on to column filters, I briefly touched on how to apply those earlier, but you really need to know how to use those. And for example, here, looking at the surgery data service, if you want to look at the surgeries in a specific year here, you click the down arrow and it shows all the values that show up in that column. So in this example, there's years 1993 to 2016. If I wanted to only look at the surgeries in a certain year, you just click on the tick box there and then hit OK, and it will show you that. And then in the box to the right, it's just another example of the surgery type. Again, it will show all values in the column. So if there are any blanks in the column, or if there are any other text that you have that aren't the variables, it will show up there, like as you can see there. But really, the HEMI, IF, and THA are the surgeries in this example study. So if I want to look at only patients who underwent THA or total hip arthroplasty, I can just have the THA box there ticked, and it will then, once I hit OK, it will sort out all the data for only the people who underwent that surgery. Now, VLOOKUP functions, so these can be fairly complicated, but they are extremely useful in terms of importing data from one sheet to another. So here's an example here. On the left, you can see in the red box at the top, it says FNF data sheet. That's my main data sheet for this study. And then on the right there, you can see this is just the data sheet for some medical data. And basically what you can do is you can take data from another sheet that is associated with a patient identifier. So for my study, it's the claim ID. So I can look up a specific claim ID in my main data sheet. I can look it up in this other data sheet, and I can have it spit out a certain value in any of the cells associated in the same row as that claim ID. Okay, and how you do that, so what I want to get is a medical cost at 2 years. So in my main data sheet, I created a variable for medical costs at 2 years. And I want to get the data from column B associated with the claim ID into my main data sheet. And you do this because in a lot of if you're getting multiple data sheets, for example, if you get one data sheet with certain medical data, you're going to do analyses within that medical data sheet to get variables that you then want to get the variables into your main data sheet. And this is primarily why you use this. So you start by putting equals VLOOKUP, and then you start your parenthesis. And then you see bold there, it says lookup value. That's going to be your patient identifier or any other sort of identifying value. So I would click on the cell A3 next, and that then is going to select that claim ID or that identifier, which you see here. So I click on A3, okay, and then you hit comma, and then you go to, in bold you will see table array. So what you do now then is you make a table of data, an artificial table that you basically do by selecting the data that you want to be queried for your patient identifier. So you can see on the right here, I have selected the entire column A and B because that includes the patient identifier data and then the medical cost data at 2 years, which is the value that I want to spit into my data sheet. Okay, so if you if you select all of that in Excel, you will see a little white box that will then also pop up, and it will show you the row, how many rows you have selected and how many columns you have selected. So in the bottom right there, you can see in that red circle, you can see 689R times 2C. That means there's 689 rows of data and there's 2 columns of data. You need to take specific note of which column of data you're going to be interested in. And this will make more sense as we go through how to do this function. So we have 2 columns. Another very important thing to do is you press F4 after you select your table. Now what this does is this basically tells Excel that as you apply the function in your main data sheet to more cells as you move down a column, it keeps the data table that you're querying in the same position. If you don't press F4 and you then apply the function in your main data sheet and you spread it down a row, or you move it down a row, then it's going to also move the data table that you're using as the data that you're querying. It's going to move that down a row, which then is going to potentially affect the data that's getting spit into your main data sheet. So if you can't remember that, just remember to press F4 after you select the table. Okay. So the next thing is it's going to, after you hit comma, after you select your table and press F4, is it's going to ask for a column index number. This again refers to the column in the artificial table that you just made that you want, the column that has the data of interest. So again, in this example, the interest is medical costs of 2 years. In the table that we artificially made by highlighting data, that was column 2. Okay, you remember when I talked about that little box that shows up that tells you which column or how many columns you've highlighted. Okay, when you highlight a table, it can be in the middle of an Excel sheet. The first column that you highlight is 1, and any column to the right of that is 1 plus whatever number of columns you have highlighted. Okay, to make it easy here, I just highlighted the first 2 columns, so it's column number 2. So in your VLOOKUP function, you press 2. Okay, and that serves as your column index number, and then you hit comma. Okay, and now this is a little easier part. So then it's going to bring up true or false. So you want to use false because for your patient identifier, you want an exact match. Okay, you don't want an approximate match. If you do true and get an approximate match, it's going to spit out data associated with patients with similar patient identifiers, medical record numbers, or whatever it is that you're using. So you want to hit false. And then you hit end parenthesis, and then you press enter. Okay, and now you can see in the slide, in the middle screenshot, okay, it then spit the data for the medical costs at 2 years associated with that specific claim ID into the main data sheet in the cell and in the column that I wanted. Okay, so you can see here the $48,416 on the right. That's from the other data sheet, not my main one, but one of the ones that I was given to from this database. And then on the left, that's the main data sheet. So then it took where that same claim ID is, and it spit out the medical cost for that specific claim ID. And this is important if some of your data sheets may have data, multiple data rows with the same patient identifier. Okay, so you need to understand what your data looks like, because if you're doing a VLOOKUP and in the sheet you're getting data from, there are multiple patient identifiers, and you want to get, let's say there's 3 rows, for example, all with the same patient identifier, and you want the data associated in the second row with that same patient identifier. If you use the VLOOKUP function there, then it's just going to take the first encounter of that patient identifier and spit in the data. Okay, so you have to understand what your data looks like. In order to do VLOOKUP properly, when you have a bunch of when you have a number of rows with the same patient identifier, you have to do something called a pivot table, which we're going to get to here in a second. I want to turn your attention to the bottom of the screen, okay, where you can then apply this VLOOKUP function to the rest of the column of your data. You can see on the left there, I have clicked on the cell that has the equation in it, and then if you move your cursor to the bottom right of that cell, a black cross will show up, and you can either double click there or drag and drop, and then it will then apply that function as it moves down the rest of the column. So if you have 1,000,000 columns, you will want to double click, and then it'll apply that function or that VLOOKUP or whatever it is you're doing to the rest of the sheet. Okay, so that's another important thing to do. And again, this is why you hit F4 when you're making your table with the VLOOKUP function. So play around with this. It can take a little while to get used to the VLOOKUP function. There's YouTube videos on how to do it that may make more sense than me right now. So one last thing, when you're copying and pasting, so delete that last second, or the last bit.
Yeah.
When you are using VLOOKUP to take data from a sheet and move it into your main data sheet, what I recommend doing is copying and pasting the values in your main data sheet or whatever data sheet you're transferring data from. I recommend copying and pasting the values to get rid of the equation in those cells, because at least in my research, oftentimes the data that I'm using VLOOKUP for, especially if you're taking it from a pivot table, it gets changed, which then changes the reference data that the VLOOKUP equation is referencing, and then you can screw up a lot of the variables that you just made. Okay, so I recommend copying and pasting pasting the values. Okay, so next, pivot tables. This is another extremely powerful tool. And you see here, again, under the claim ID or patient identifier in this particular data sheet that I was given, there are more than 10 rows there, all associated with data for that one patient. Okay, you can see the first service date there, which is in the other red box. There's a bunch of different dates. Okay, so how are you going to extract from that data, let's say, for example, the earliest service date or the earliest surgical date? If you just do a VLOOKUP tool and you use it with a data sheet that looks like that, you're going to get the first one again that you encounter. So in this case, it would be 6/11/2007, and I'm looking for the earliest one. Okay. So what you do to get a pivot table is you go to your Insert tab at the top, and then you click on Pivot Table. And you got to make sure that your entire sheet there gets selected, like seen in this screen. Okay. And then this screen will then pop up. It will show you you can select a table or a range of data. If you don't want to use the entire table, you can adjust that there. And I like to put this in a new worksheet, so you can see in the bottom red box, you want to, it just makes it easier. If you put your pivot table in your main data sheet, it gets kind of cluttered. Okay, so this is what it looks like when you put your pivot data in a new sheet. So it's a really powerful tool in that you can look per patient identifier for a number of variables, and it can sort them if there's multiple, variables associated with that patient identifier in that sheet. So the row labels, you can see it's the claim ID. If you look on the right, there's the pivot table fields. I moved claim ID down to rows. So if you have a column of all your patient identifiers, you're going to want to move that down to rows. You can also apply filters here too, which again are really helpful. And then down at values, so I put first service date. Okay, again, just think of that like surgical date. I put that in the values square there that you can see on the right. So you see min of first service date is what shows up. That's just kind of the default function that shows up. You can click on the arrow next to the min of first service date, and you can change that to sum, max, and a number of other functions. Okay, so now with the filter, let's say I wanted to get the earliest service date that each subject underwent an irrigation and debridement, okay, or IND. So on the filter there, you see a 1. So you click on the filter and you'll click on whatever you want to filter for. In this case, I wanted a 1, showing that which then only includes data on patients that underwent an irrigation and debridement. And then I want minimum of first service date, which then gives the date of the earliest service date associated with an IND. And it's going to give these typically 5-digit values for the date, because that's just a numeric value. If your column is formatted correctly in your main data sheet or wherever you're going to transfer this data to for date, it will show the correct date. So here I'm showing what other functions you can apply. So again, you click on that arrow on the right of min of first service date, you click value field settings, and you can see there's sum, count, average, max, minimum, product, etc. Okay, so you can do this a number of ways. Okay, so you have your pivot table, and then you're going to use VLOOKUP to transfer this data to your main data sheet, kind of how I explained earlier. And again, you want to copy and paste it, because if hypothetically you do a VLOOKUP and you transfer data from your pivot table into your main data sheet, but then you change your pivot table, that's going to throw off all the data in your main data sheet. So copy and paste values there is really important. And that's kind of it, really. There are a lot of powerful tools you can use in Excel to really manage your data, but hopefully I've applied some general principles that you can use and apply towards managing the big data from a database, especially if it's given to you in multiple data files. And then hopefully I've given you some information on functions that you can use to create the variables that you need to subsequently use for analyses in your stats software. So thank you.